I think that's the exact right way to do this. If we're going to get applications to serve targeted geo-targeted ads, hey, make developers aware of it, and make sure they're telling their users about it. Right. Makes sense.
And one of the lessons here is just we need to see more developers and SDK developers act like AdMob. So AdMob is taking a really good stance in how they're doing this. The question is the million other tiny SDKs that are out there that really haven't thought about this at all that could be exposing users. That's what we need to be aware of. And we really, really encourage developers to take, as much as they do security, users' privacy seriously.
So the lesson we learned today is that developers don't always know what's inside of their apps. And we hope to encourage developers to really pay attention to what they do put inside of their apps. Third story, I Spy. So we found a huge proportion of applications having third-party code, and we found that users and developers don't always know what's going on. What about other sorts of reasons why somebody might want to access sensitive data? Yeah. Are there apps that could be spying on me? And so we actually dialed up our analysis a little bit and said, okay, what sort of apps are accessing like all sorts of really gnarly data? Your IMEI, your IMSI, these are GSM identifiers that can be used for fun things. I hope you guys are staying for DEF CON. We'll see the cell phone sniffing talk. That'll be a good one. Yeah. Browser history, contacts, location, and there's a gamut of other things that you can access and people have been talking about. So the first thing we found was an application by a developer called RxS, and it claimed itself to be a system utility. There were multiple apps in the market, and they all had fairly innocuous names, and a lot of them calling themselves system utilities. Android 15X, Android 16X, Android 20X. Sounds like a home exercise plan, I know. And we say that inside all these applications, they're shuttling a lot of data to mobilespylogs.com/web API. I don't know about you guys, when I see anything connecting to mobilespylogs.com, I get a little nervous. So let's pull out our Icelandic disassembler and look what we see. Ooh, that's interesting. Get SMS details, contact details, URL details, and call contents. Yikes. So what happens when we actually go look at what this site is? Oh boy, it's MobileSpy. It's our good friend. It's a very popular mobile spy tool. And
who are not our friends.
Depends on whose side of the spying you are on. So actually, what they're doing is they're instructing their users to basically go to the Android market and download these kind of masked applications, which is kind of interesting. You could say that there's a low probability for me to just go download this accidentally, like downloading a system utility that accesses all like contact and location data. I'm going to immediately click cancel. But there are apps in the market that do something different than they say they're doing. And this is a fairly interesting kind of precedent and not always a good thing. When you have all sorts of apps floating around that do a lot of really gnarly things, but they don't actually tell you up front, hey, we're doing a whole bunch of really gnarly things. The Android permission model mitigates this actually quite a bit in the sense of you can actually see what it's doing. But a lot of users just click OK. I mean, if there's anything we know in security, the affirmative button gets clicked far more often than the negative button.
Right. And one of the great things that we're seeing in the context of Android is there is fine-grained understanding of permissions, and there is the community policing model where in the context where we see bad apps, we have the ability to, in many cases, go ahead and address those and pull those out of the market.
So an aside, there was a great talk at Blackhat DC this year. And there was a proof of concept spy phone application that only actually used permitted APIs, and they accessed a whole bunch of data on the iPhone. I don't think Nicholas tried to get this in the iPhone App Store, but I think it's really interesting. It opened a lot of people's eyes, myself included, as to all of the things that are just right there for an application to take. On iPhone, users don't know all of the granular permissions. The exception is location and push. But generally speaking, all of the stuff he did, there's no user notification at all. Some of you guys might have seen this week.
Or downloaded it.
Or downloaded it before Apple pulled it. There was an iPhone phishing app.
Flashlight, not phishing.
Or sorry, well, you're right, sorry. It was a flashlight application, not a phishing application, entirely different. Developed by a 15-year-old. He created this flashlight app that looked and felt and quacked like a flashlight app, but also had a functional SOX proxy inside. So if any of you guys have an iPhone, you know that you're not supposed to tether on AT&T. It's a premium service, and so having an app that allows you to tether, allows you to get around that premium service. Obviously not something Apple wants to have in the App Store. This application was actually accepted. It was live in the App Store. Once everyone found out about it, Apple removed it. I think the really big message here, yes, it's cool that we can tether and like 1,000 people got access to this, but Apple's never claimed to have a silver bullet, and no security person would ever claim to have a silver bullet. They're keeping the App Store safe, but I think it's really important to realize that no security measure is 100% perfect. The fact that a 15-year-old sneaked an application that seemed like a flashlight app, but was actually a SOX proxy into the App Store is very significant. Imagine what the Russian business network could do if they put 10 developers on sneaking something into the App Store. I mean, there's a lot of very interesting things that could happen there. And I think it's important that we all are vigilant in the type of apps we download and not just be complacent to say, oh, Apple is solving security for us, wave the magic wand, we don't need to worry about it anymore. It's up to everyone to keep the ecosystem safe. Lesson learned here is apps aren't always upfront about what they do. It seems obvious, but I think it's worth kind of having people pay attention, especially users who may be tempted to think, oh, it's from an app store, it's from a trusted company, everything is safe in it. And we want to say, hey, it's a lot safer than having nobody helping keep things safe. But there's no user ignorance is bliss that can go on here. Users still need to pay attention and be vigilant. The fourth story, the orange wallpaper. So we found some spy apps in the wild, and those are obviously bad. What other sensitive data could apps be getting? Maybe not knowing where I am, who I call, what I ate, but things that somebody could use to profit or for other motives. Phone number, IMEI, IMSI. There's only a couple hundred of these in the market, so it's actually a fairly tractable problem once we narrow down the applications that actually access these APIs to analyze a few of them. First, we looked at patterns. Are there any developers that have a whole bunch of applications in the App Store? And wow, Jackie Wallpaper has 76 apps, and I don't even know how to say the name, has 8 apps. That's quite a few that all access these same permissions. That seems a little sketchy to me. What are these apps, you might ask? They're all wallpaper. Wait, why does a wallpaper need to... Okay, well, let's not
guess which one is the most popular.
So let's not distract ourselves with silly security questions. I want to get ponies. My phone is pimped. Wait, why again are wallpaper accessing my phone and IMSI and IMEI? It's a good question. So we Wiresharked it. You probably can't read this, but this is what happened when we ran the application. So we installed the wallpaper app, we got ponies, and this HTTP request was sent in the clear, mind you, to a server. My SIM serial number, my subscriber ID, my phone number, and my voicemail number. I don't know how many people in the room actually put their password encoded into their voicemail number, but you might not want to.
Yeah.
Okay, so it's going to imnet.us. Obviously, this is pretty bad for a wallpaper app to be sending all this information off of my phone, but who is it actually sending it to? Secondarily, there were a whole bunch of applications from 2 developers. It actually turns out, digging into a few of these applications, that the offending code is actually the same. And so I don't exactly know why they have the same code in them, but they have the same class, and it's the same implementation, and it's not anything that's documented anywhere in the world that I can tell. What is this sync device info service doing, this mysterious thing? Our friend Boxmolly again, getting the device ID, line 1 number, someone, all the data we saw floating over the clear. Okay, so this is our smoking gun. Who again owns imnet.us? Oh, hi. But nobody would download a wallpaper app that reads your phone state and identity, right? Does anyone want to take a guess as to how many downloads in aggregate these applications have? Just throw out a number. Oh, come on, 100,000, go higher than that. Higher than that. Yeah. So this is estimated via AndroLib. Caveat here is Android applications only can tell you if they have more than 250,000 downloads. But between all of these applications, these two developers, there is a lot of downloads.
And you can see the power of the App Genome project now, right? We find one app, then we are able to leverage that to look at all the apps that do this. So initially, Kevin and I thought, oh, this is only 50,000 people who've been impacted by this. No. When we dug in, it's much more than that.
Be careful what wallpaper you put on your phone. Oh yeah, there's a lesson here. Apps take advantage of stuff. Yeah, who would have thought? So if an application requests permissions and you put it on your phone, you can probably be pretty sure it might take advantage of those things.
Right, and this is something, it's not one platform or another. I mean, this is something that everyone needs to be vigilant about, and this is not just the OS developers, it's developers themselves, security professionals, and consumers. We all have to take this super seriously. Mobile platforms exploding so quickly now that clearly people are looking at this in a way that they're trying to take advantage of it. So if we sit there and don't do anything about it, we're going to see this become pretty common.
So we went through a lot of that pretty fast. So what did we learn here? First, not all apps that access sensitive data are bad. The key thing, yes, we did find some bad things in the wild, but doesn't mean that a soundboard that is accessing your contacts is really doing malicious things. Developers, message to you, pay attention to what you put in your apps, pay attention to what you subject your users to, especially when developers are bringing in third-party code. As a user, apps may not be saying what exactly they're doing. Do you trust app descriptions? Android, look at the permissions. If you're a IT administrator, encourage your users. I mean, education is obviously part of it. Finding bad things and removing them is another part. And educating everyone is part as well.
Yeah.
And then apps, taking advantage of their capabilities, obviously it's going to happen. So we kind of talked about, imagine there's a hypothetical vulnerability. Such a thing will never happen on a mobile device ever. And we want to figure out, one, are there apps that are vulnerable in the market? Two, is there anything exploiting it? These are pretty good questions to ask, especially during security response. Imagine we disclose said hypothetical vulnerability to a major vendor, and we want to have data about whether people are being exploited in the wild or not to help determine whether we should publicly disclose. Right? This is a very hot topic question. I'm not going to get too far into it. But the idea being that if a vulnerability is being exploited rampantly in the wild and users can do something about it, even though there's no fix, many would argue that it's beneficial to the end user to know about the vulnerability and be able to take a workaround fix. And if we can identify bad things in the wild that are exploiting a vulnerability, that might drive how we choose to guide our disclosure discussions, and having evidence to actually support those discussions instead of speculation as to somebody might be thinking about this, somebody might be exploiting this, so on and so forth.
Right, so I mean, what's so cool, we have real data. Not only can we discover what's happening very quickly, we can respond to what's happening super quickly.
So let's take an example of this account hijacking vulnerability we talked about earlier. On Android, apps shouldn't be able to get around their permissions. We talked about modulo root. And let's imagine we find all applications with read log permissions, right? In order to exploit the hypothetical service we described, you need to be able to read the logs that app spits out. And actually, if you look at the number of applications in Android that request read logs, it's only a few hundred. So it's actually a tractable problem to solve with Red Bull. And so we can automate static analysis to identify code that accesses log data. And we can actually go look at